Give a possible factorization for the following polynomial graph. Do not multiply out the factors. Identify the stated characteristics of each graph. Pay attention to multiplicity and end behavior. Well, in fact, notice the first part that we have on the review sheet, which is the leading coefficient. And if we look at this graph and we look to the far right, what we see is that we're going downward. Our leading coefficient is negative, so we need to have a negative out in front of our function. Now, the next thing that I personally like to look at are the roots. And we've got x equals -2. We have x equals 0. And we have x equals 1. And the reason that I write them like that is because if we add 2 to both sides, then we, not x equals, we have x plus 2. And that's going to be one of our factors here. And we can subtract 0, we can add 0, so we can have x minus 0, we can have x plus 0, but do we really need to write the 0? And the answer is no. So I'm going to write the x. And then we've got x equals 1, so if we move the 1 over, we're going to get x minus 1. And I am going to write it in a little bit better form here in a minute, but remember what the directions say. Pay attention to multiplicity and end behavior. The end behavior here helps us with leading coefficient. We already have that written. If we go back to our first value right here, which is -2, goes with the factor of x plus 2, what we see is that we touch, and we have this U shape right there, which means that our exponent's a 2 on that. If we look at 0, once again we touch, and we've got a U shape. The exponent on the x is also 2. And over here on 1, for our last root, which our last factor then is x minus 1, we cross, or we slice through, our exponent is a 1 on that. And that is fine. If you leave your answer like that, I'm fine with that. Typically, the way that I write my factored form is I would write negative x squared times x plus 2 squared times x minus 1. And I am going to leave that exponent of 1 on there. Again, doesn't matter. You do not have to write the exponent of 1. But our next question here is the degree. And the degree is going to be 2 plus 2 plus 1. 2 plus 2 plus 1 is 5. And what we call a 5th degree polynomial is we call it a quintic. We can look at our picture to determine the end behavior. As x goes to negative infinity, that means as x goes this direction, what's happening to our graph? We're going upward towards positive infinity. As x goes to positive infinity, going towards the right, we've already determined that our graph goes downward towards negative infinity. Our domain, 95% of the time in Algebra 2, is negative infinity to infinity. And because we have end behavior that's going in different directions, one is going up, one is going down, our range is also negative infinity to infinity. With respect to the range, ask yourselves, do you have a high point or do you have a low point on the graph? If you have a high point or a low point on the graph, the range will not be negative infinity to positive infinity.